metaphors. Let's get to the next question. We still have time, I suppose. Yes.
Yes, sir.
This is a very long session.
Yeah.
Yeah, it's okay, I suppose. I don't really have much to do anyway. Huh? Yeah. Next up,
27, sir. 27.
27. 25, 26 are okay.
Yes, sir.
Among the following pairs of compounds, identify enantiomeric pairs. Okay. Enantiomeric pairs. Okay. So option A are the
Yes.
enantiomers.
No, sir. No.
You did not mark that, yes?
I didn't mark that. No.
I just wanted to confirm how much shouting is warranted.
No, sir. I didn't mark that. No.
Option C.
Oh, yes. Enantiomeric.
How do you know they are enantiomers?
Sir, you can put the ethyl on the bottom, and then you can see that they're mirror image, but then not supernatural.
So the idea here is very straightforward. Any two groups you swap, or you put a mirror. यहाँ पे mirror डालो, you get the first one stop part there. Right. In the bottom here, they have swapped two groups. When you swap two groups at a chiral carbon, you're going to be having the mirror image at that location being obtained. Which two have been swapped? These two have been swapped.
Yes, sir.
So you're having a mirror here also. So if this was R, this will become S.
Yes.
In this case, if this is R, this will become S. I don't know whether it's R or S. I don't care.
Yes, sir.
Just putting shit up for the sake of putting it up.
Yeah. Yes.
So yes, option C is mirror images. Delhi. What's
yes,
the only other chiral carbons? One carbon is chiral.
Only one is it, yes. So both
And
are.
that is perfectly mirrored over here.
Yes, sir. Yeah.
Right? There's a mirror image technically.
Yes,
In
sir.
one case it's coming towards, in the other case it's going away.
Oh, yes, sir.
Everything else is same. That
Yes,
means
sir.
they are mirrors.
Yes, sir.
So Delhi is also correct. So C and D are fine. Only thing you have to really check for is Bombay.
Yes, sir. Yeah.
How do you check for Bombay?
Sir, we can just you can convert as a horse, or you can.
Good.
Yeah.
You do the hard approach. No shortcuts there. Why?
Yeah.
Because Newman is not something where you use shortcuts. Newman, our brain cannot comprehend properly. Fischer and Sawhorse, we can comprehend better. Newman is something which is very weird. Unless and then you have extraordinarily good spatial arrangement in your brain, you should not be able to comprehend. I can't comprehend Newman properly. I prefer drawing Newman in the Sawhorse or Fischer and then getting shit done. Can you do that? Is that a problem for you, or should I explain how to do that?
No, sir, I got that. Yeah.
What was your answer for this?
Yeah, I ticked this, but then it was not. It was wrong, I think.
What do you mean you ticked which? What?
This B option, but then B is actually wrong.
Bombay, yeah?
Yes, sir.
Why did you get it wrong? What did you do?
Sir, in the exam, I did Fischer. I turned it to Fischer projection. Sir.
Okay, let's do that. So we are going to be having okay. Now, before you turn it into Fischer, another easy approach would have been you get it into an eclipse.
Yes, sir.
Right. So everything is perfectly opposite. That means it's going to be same as this.
Perfectly eclipse.
Right. Something like this.
Yeah.
So it is going to be something like this. Now drawing your Sawhorse or Fischer is much easier.
Yes, sir.
So if I'm drawing the Fischer, it's going to be this. right?
Yes, sir.
Now, is
Second,
optically active or inactive?
inactive.
That's the key there, right?
Yes, sir.
Look at the other compound. That's also the same.
Yes, sir.
So are these guys enantiomers or are they the same?
Identical.
Yes. You understand the idea here?
Yes, sir.
So your mistake was you saw that they are looking opposite, but you did not notice they are optically inactive. Correct or wrong?
Yes, sir. Correct.
So you should make sure that you're checking it in the correct manner there. Anyway, this is an acceptable error. It is not something which you would have noticed the first time you're seeing a question like this. Okay, it's not too shabby. But it's an easy question.
Yes, sir.
You've made a blunder, certainly. Next one.
So 27, 28, I missed out on one option.
So 28.
Yeah.
What did you miss out on? Which option?
B, sir.
What's the mistake you made there? Why did you miss out on B?
Yeah, I was
It's correct now.
Yes, sir. B is correct. Yes.
Why did you miss out on B? Close your eyes. Try again. Dude, do the breathing shit again and see why you missed out on B.
Yes, sir.
Think. I mean, stop thinking for a bit and then suddenly think. Focus on your breathing. A nice slow breath in and an even slower breath out. Nice long breath out. Focus how the air is moving into your lungs. You can feel the air from your nose going in through the passage slowly. You can feel it coming out slowly. You'll be able to feel the small changes in your body as you're breathing the air in, the small changes as your diaphragm, what to say, closes in and pushes the air out. Point your brain suddenly towards that question. What fucked you up? What confused you there? What confused you? Don't think too hard. What is the first thought which popped up?
I think
Think now. What popped up first?
something maybe about elimination.
Yes, exactly what I thought. Na and acetone, you basically were looking for that to be something which does your chlorine elimination.
Very yes, yeah. But then only single chlorine is there.
Yes,
I
yes,
agree.
yes. Because you are looking for that, you do not think about what could happen over here.
Yes,
You
sir.
assume there will be no reaction, you do not think beyond that. Fair?
Yes, sir.
This breathing technique is something which you can use for yourself. You have to use it. But the idea there is you should not think beyond that. After you have cleared your brain, you point it in that direction. The first thing which pops in your brain, however weird it sounds, however weird it feels, that is where your mistaken assumption is usually. This works in everything. It doesn't work just for this. If you really want to find out how you can basically improve your efficiency or how you can go into a more serious monk mode, do the same thing. Think of close your brain and like what to say, shut your brain off. Ask it the question, what am I wasting time on still in my life? It will point out. But it is very painful because it will only point the truth. You have to be able to accept the truth. The truth is going to be the most harshest critic you'll ever find. Because you cannot lie to yourself. And it will point out. Trust me, it will point out. I've tried this a bunch of times. I hate myself a lot. Because I've seen too much of the truth there. Next up.
Yes, sir. The 29th question, sir.
Which option?
A.
Should we go there again, or you already know what your mistake is here?
I know what the mistake is, sir.
What's your mistake here?
So the carbocation will be more stable when
The
it's
chlorine.
there
Why?
because of the plus side. So plus M, plus M.
Plus M. Because
Yes,
of
sir.
difference.
Yes, sir.
But you jumped the gun and you assumed that, oh, chlorine hai, I'm going to be having minus I effect, or you basically thought chlorine electron withdrawing group outside away from it.
I
One of
thought of
those,
this, I was just
it's one of those two. Mostly it is the second one.
yeah, something like that. I was a little unsure, so why risk?
So say sorry to yourself each time you make a blunder like this. I even discussed this shit with you just towards the ending. I told you how when it comes to a, what to say, alkyne and HCl, blindly do the addition twice.
Yes,
Right?
sir.
And I gave you reasons for both.
Yes, sir.
In
The
one
first
case,
one.
carbocation cannot rearrange. In the other case, the carbocation is better at that location because of resonance.
Yeah. Yes.
Is it exactly the same?
Yes, sir.
Next up. So 29, option A you messed up, is it?
Yes, sir.
Okay. 30.
I got it, sir.
31.
1 second. 31, I got it, sir.
32.
32, I did not get. I got different. Yes, sir.
How many of them are more acidic than this fellow? Okay, all right. So we are given 1, 2, 3, 4, 5, 6, 7, 8 compounds. Okay. Some fools sometimes mark answer as 9 in these kind of questions. Were you one of them?
No, sir.
I had to confirm.
No.
You did mark something similar to this in the previous question in the previous paper.
Yes, sir.
Okay. So cyanide. What type of a group is cyanide?
Minus withdrawing.
Weak or strong?
Strong. Strong minus M.
Strong, powerful electron withdrawing group.
Yes, sir.
Okay. All right. So definitely phenol is going to be weaker than that.
Yes, sir.
How about chlorine?
Chlorine also will be weaker than
How about CH3?
CH3 also.
How about OCH3?
That will also be weaker.
So you've already lost out 4. So
Yeah.
answer has to be between 0 and 4.
Yes, sir.
Okay, beautiful. Nitro,
Yes, it's stronger.
stronger. NH2.
No.
Now, other two fellows are full-fledged acids,
Yes, sir.
sulfonic and carboxylic. So obviously, they are more acidic.
Yes, sir. Yeah, they are acidic.
Answer is 3 then.
Yeah, it's 3. Yeah.
How could you cock it up then? What was your mistake here? What was your answer here?
1, sir.
You know where you fucked up, right?
Yes, sir. I got it.
Should I point it out?
It's okay, sir. I got it.
Where did you fuck up? You tell for yourself. Openly tell it out.
The acid where there are 2 different acidic groups. Which one would?
You
That
did
is
not
true.
think of these as acids.
Yes, sir. I did not think of it. No. I knew something was wrong between those two, but then I wasn't sure, so I just kept.
No, it is not about sure. You did not want to see it carefully.
Yeah.
What have I given you in the order there? I gave you a fucking full-fledged order for acids, correct?
Yes, sir.
I'm sure your teacher in school has also given you one of those, or
Yes,
something
sir.
similar to that. Maybe
Yeah.
not as detailed as mine, but something similar to it.
Yes, sir.
Or maybe more detailed also, maybe. I don't know. Your teacher has got enough experience, I'm sure. You
Yeah.
sound older than me.
Yeah. Yes, sir.
So, what should you be? Sulfonic acid is like it's the derivative of sulfuric acid, bro. What the fuck?
Yes, sir. No.
Sulfonic acids are generally much stronger than carboxylic even.
Carboxylic acids is better.
They take the topmost position.
Yeah.
Okay, 33.
33. Yes, sir. I got this one.
Correct or wrong?
Wrong.
This is a very weird question.
Yes, it was.
This is not something which you can solve nicely. This is one of those shitty formula approach questions where if you use a formula, it'll work better.
How is it even possible? I don't get it.
See, they're asking geometrical isomers here, correct? Huh?
Yeah.
So the way to proceed here is you have to use up and down. Think of it as what to say, or towards you and away from you, however you want to call it.
But how?
You have to hardwire yourself into doing it. So let's say this can be up or down. This can also 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 be up or down.
Those are different cases.
Yes. Now, you have to also remember that carbon 1, carbon 2, 3, 4, 5, 6 left. You're going to be having 1 and 4 being the same.
1 and 4
are going to be the same. 3 and 6 are going to be the same.
Yes, sir.
So this is something where it's going to be something which is hard work if you want to sit and do it by hard coding. In this kind of a question, that's why I said formula type of shit will work. I'm quite sure there would have been a formula type of shit which has been given to you for nothing of this sort has been given.
No, sir.
You would have been given a formula type of shit for checking optical isomers and crap.
Yeah, optical isomers.
Apply that formula divided by 2. Why?
Because symmetric about. Yeah.
That will work. But that is going to be a cheap methodology. I don't remember those formulas. I don't care about those formulas. This is a question which I would skip.
Numerical, so I can attempt.
You can attempt. What did you attempt and what was the correct answer? 6 answer or 8 answer?
8, sir.
It's one of those 2 always in this kind of crap. The game is always going to be about what to say, guessing it properly. And in this case here, when you have seen this question once, remember it. Your brain is capable of remembering this kind of crap easily. Let's not even go there that it is tough and how do I know? No. We both know it is easy for you to remember. It's not that complicated. Remember it. Next time when you see it, don't even care. Put the answer and walk off. Some things you have no. This is not a worthwhile question to sit and waste time on. You understand what I'm explaining, right?
Yes, sir.
Doesn't matter what is the approach. The approach is what I just showed you. You put it as up and down and you sit and list it out and then you cut off cases. You're going to be getting a large number, a huge number of possibilities. Then you strike. That is the hard way approach, hard coding approach.
Yes, sir.
But it's not worth it. It is not worth doing. So the easiest way is remember the thing and move on. Don't waste time on this too much. How do I know this? Because I have seen questions of this sort for this compound. What is this compound?
Oh, Linden, Gamaxine.
Gamaxine or BHC stand for
666.
benzene hexachloride.
Benzene hexachloride. Yes. Yes, sir.
So that is basically instead of methyls, you're having chlorines there.
Yes, sir. Chlorines.
Even though they call it benzene, it's not benzene really. It is cyclohexane hexachloride actually, if you really look at it sincerely.
If you chlorinate that benzene. Yeah.
So it is going to be something where that is a more common case which people ask normally. People ask and it is something which I've seen before at least. And it is not worth wasting time on. It is sincerely not worth wasting time on because you'll have a whole bunch of optical isomers also. It's too complicated. Sitting and doing it is not worth at all. Move on. Next question.
What's the next question? Yes, sir, I got this one.
35?
Yeah. So
35,
34 I didn't get. 35 I got. 34 I did. Sorry, once again. 34 I got. 35 I didn't get. 35 I didn't get.
35 you did not get or 34 you did not get?
34 I got, so 35 I didn't get.
34 you got, 35 you did not get.
Yes, sir.
35 is a painful question.
Yes, sir. My teacher gives this.
Last was equally painful. Okay. Now let's have a look. How many of the following is or are correct?
So, sorry, I didn't attempt this question. My bad.
You didn't touch 35 and 36, huh?
No, I did 30. Oh,
38.
Just a second, sir.
Yeah.
So 33, I got it wrong. 36, I don't have time to do.
36 you do not have done. 35 and 36 you have not done, no?
No, sir, I did one of them. I did the 36th question, ma'am.
36 was correct. Okay, how many of the following statements are correct? It's only about
No,
carbohydrate.
36 was wrong. 36 was wrong.
35 you got correct then.
Oh, I think I guessed it correct. Oh,
Let's
wow.
have a look at both. It doesn't matter.
Okay.
So we're going to be having in this particular case here, 35, how many of the following statements are correct? We are having acidic strength mentioned there. First one. First option, is that correct?
Just a second.
Which should be the most acidic?
The 2 should be the most acidic.
Why?
It's attached to 2, I mean, withdrawing. Both of the atoms connected to that carbon inductive effect.
So this location and this location are both going to be, what to say, alpha.
Yes, sir.
To this.
Yeah.
So both are similar. And this location here, number 2, is going to be having a sulfur, which is a minus sign. So 2 greater than 1 is acceptable, and 3 is going to be the worst.
Yeah.
Okay. Next is we're going to be having acidic strength of this one over here. Sulfur has empty d orbitals and empty p orbitals, empty d orbitals available. Sulfur can basically delocalize a negative charge much better than an oxygen. Oxygen cannot.
Yeah. Yes.
Second one is also correct.
Yes, sir.
Or fine?
Yes, sir. Third,
carbocation stability. Hyperconjugation is what you check for in the first and second compounds there. Which one will have better hyperconjugation, CH3 or CD3?
H3.
H3. So one has to be better than 2. Yes?
Yes, sir.
And between 3 and 4, what should you check? Should you check for hyperconjugation or inductive effect?
Inductive effect, because it might have.
Which is more inductive?
D.
D.
CD bond, yeah.
Negativity wise, tritium is less than deuterium, less than hydrogen.
Sir, in what? Can you repeat?
When you're looking at electronegativity for tritium, deuterium, and protium,
yes, sir.
You're going to be having tritium being lesser electronegative compared to deuterium compared to hydrogen.
Yes, sir. Yeah.
Which is why the carbon tritium bond is stronger than the carbon deuterium, stronger than the carbon hydrogen.
Yeah. Yes.
Which is why hyperconjugation is worse for tritium, then for deuterium, then for protium.
Yeah.
So order given is correct.
Yes, sir.
Next, 1 and 2 are diastereomers. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So 1 is going to be cis and cis. 2 is going to be trans and cis. Yeah, they are diastereomers. How?
Because
trans are diastereomeric.
yes, sir.
You understood what I did there, or you did not?
Understood, sir. Understood.
Okay. 5. Order of basicity.
3 most.
Most basic is of course going to be my 3.
3 only. 3 only. Yeah.
Then my 2. Then 1. Correct only here. No problem.
Yes, sir. That's also correct.
No problems with this.
No, sir.
Okay. 6th one. SN1 reactivity order for this. So first is going to be a benzyl. Second is going to be benzyl with an oxygen supporting. Third is going to be a benzyl with nitrogen supporting. Oxygen and nitrogen will be donating lone pair and supporting, correct?
Yes, sir.
Which will donate more willingly, oxygen or nitrogen?
Oxygen.
Nitrogen, less electronegative.
Oh, sorry, sir. My bad.
So 3 greater, 2 greater than 1 is correct.
3, 2, 1. Yes.
Next. B, C, D are aromatic compounds. Okay. Option A is anti-aromatic.
B is correct.
B is aromatic, yes, because oxygen will have lone pairs, which will come
D
in.
is also correct.
C is going to be aromatic, of course. And Delhi is going to be non-aromatic. No, actually, Delhi.
No, it's aromatic, right? 6.
No, Delhi is not aromatic. Because you're going to be having oxygens not necessarily willing to donate at the same time. Da? Only one oxygen will donate. Na? You need 6 for aromaticity.
That's okay.
There is no resonance between oxygen and boron also completely. No, oxygen will donate to one side, it will not donate to the other side. So no, Delhi is not aromatic.
Okay.
No, that was not a proper sounding. Okay.
No, I understand. I understand. Both will won't donate at the same time, right? The loan pay.
Yeah, both will never donate at the same time. You understood that part,
That's
there, right?
true. Yes.
And
Yeah.
the boron doesn't have any shit anyway.
So, but the answer is given as 8. Like all of them are correct.
All of them are correct. Then let's
That's
check.
how it's
Give me a second. Let me check it.
Yes, sir.
It's going to be feasible. This will go here. This can go here.
Sir, yeah, it's actually wait. Actually, I think it's
Anda, they are correct. This is a feasible structure. I assume that you can't donate at the same time, but you can. Look at the structure I've drawn here. This is going to be a feasible one.
okay.
You understand how it's going here?
Yes, sir. Yeah. Fine.
So they are not wrong here.
Okay.
Stupid preconceptions can even screw somebody like me. Best is to put pen to paper and draw and check.
Yes, yeah.
Next, 8th one. Least likely protonation site in the conjugated alkene is least likely protonation site.
Okay. Yeah.
Yeah, why?
Just a second. Resonance at B, resonance at C, resonance at B.
Oh, no, don't look like that. Look by protonating that and see what you get.
Yes, sir. Yeah, we have.
What do you get?
All the other places you get stable.
Have this shifting. Stop. Don't look at all the other places. That's what I'm trying to tell you. Don't look at all the other places. Protonate that. Find out what you get. Then see why that is worse.
Anti-aromatic.
Correct.
Yes.
You understand the problem now?
Yes, sir.
So this anti-aromatic. That is the real problem.
Got it, sir.
Issue here?
Yes, sir.
Okay. Next up. How many of the following statements are correct again? So first one. Most stable carbocation is A. Correct.
Correct. Hyperconjugation. Alpha hydrogen.
Good. Next, acidity order is given.
I don't know. I know.
What do you think? What's the first compound's name?
Picric acid. Squaric acid.
Squaric acid. Even if the other guys do become an acid, they're all going to be phenol type of shit. Squaric acid you are familiar with. So this one, I would not go with this as of now. If you have to like directly guess over here, you're short of time, it looks wrong. So keep it under advisement for the time being. We'll come back to it afterward because I'm not sure of this as of now as of now. So as of now, I'll put it as wrong, but that is purely from the time point of view, which means we'll have to try it out again by putting pen to paper, depending on the other options. If they take too much time, then I will not waste over here. Not worth it. Exam point of view. Now we'll sit and solve it. But if it is not going to be taking too much time, sit and solve. Remaining options, if they are like tuck. Let's see how. Third one, we are going to be having these two guys as positional isomers. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, they are positional isomers. Correct?
Yeah. Yes, sir.
Next,
Correct.
Br and C2H5 and C2H5
Yes,
are identical. Correct. Next is going to be CH2OH and CH3 and OH are positional isomers. Technically, is it correct or wrong?
I mean,
Naming wise, it doesn't look like it is correct. But
if you name them, it's
look
going
at
to
the position there. If I remove the OH from that location and I put it somewhere else on the ring or anywhere else,
phenol.
that is technically positional only. But the problem is one of them is a regular alcohol, another is a phenol.
Yeah, exactly.
Properties completely end up changing.
Hmm.
Calling them positional isomers is again very, very dicey. They look like positional isomers, but ideally speaking, they should not be termed as positional, is what my basic common sense tells me. But this is a controversial one. Next, these two guys are chain isomers.
Hmm.
Calling them chain is not good. Calling them ring chain is better.
But they're not ring. I mean, chain.
Sorry?
Ring chain is like when a ring and one is ring and one is chain, right? But then here both are rings.
Yeah, but they are different rings.
Yeah, that's true.
They are different rings, no? How would you call them then? They are ring chain only, no? Technically.
Somewhat, yeah.
So if I have to call them, I would prefer to call them ring chain isomers, not just chain isomers. So I'll say this is also wrong. Next, 7.
Correct.
A, B, and C give the above product on aqueous H2SO4. A will give correct, C will give correct. Delhi will not give.
Yeah.
A, B, and C give only. Okay, huh? A, B only I have to check now. B. Sulfuric acid. Let's say it gets protonated. ये try करना पड़ेगा again. Yeah, we'll probably get it. So 7 should be correct. So answer as of now looks like
6 out of 7.
it's not. So 1, 2, 3, 2 are
5.
wrong. 2 are wrong for sure. 4 or 5. What is the answer given?
6.
6. That means one of these is also something which they are assuming to be correct. And they are taking this also. That means they are taking second one is correct. And they are taking one of these to be correct. Which ones were there? 5 and 6. 5 is controversial. 6 is also controversial. Not worth debating over here. Get me more specifics, then we'll debate which ones they are arguing about. Have they given you a solution type of thing and they have mentioned which ones are correct?
It's written except 5 all are correct. These are facts and conceptual.
Except 5 they have mentioned all are correct. That's exactly the detail I wanted. Okay. So 6th one they are calling it as ring chain.
They said it's they're facts and conceptual. So I guess
Okay, fuck it.
go with it.
And they are going with 2 also being correct. 2 is the more interesting one. 6, I still debate the fact that it is correct. Calling it chain doesn't make sense. But I'll give them the benefit of the doubt. It doesn't make a difference. So 5 or 6 is the answer now. So 5 or 6 now I have to go for second option and check out. Second option may that big guy na. Squaric is all right, obviously. The way to debate this option would be directly to check if we can get aromaticity in the other ones. I'm not sure of 2. Second option, I'm not even sure whether it is making sense because my brain tells me it should not be correct. So I'll have to actually confirm data then. So even if I draw, I'll have to waste a lot of time and check now. My logic part of it tells me it should not be working out because squaric is aromatic. Whereas the third option should not become aromatic. Second option also should not become aromatic. But second option, let's try once. I'll draw and check. Instead of looking at my brain, just draw and check. Draw pen to paper again. So let's say I'm shifting this fellow inward over here, and this fellow will shift here. Okay. So I will be getting OH. Oh yeah. Okay. They are right, Duck. They are correct. How is it that they are correct? Originally, my problem was that this particular oxygen is not going to be connected to these in any way. All right. This and this are okay. That is, this one and this one are all right. They will definitely have resonance with this part over here. They are similar to the squaric acid bit. But my original doubt was that this fellow, how do I connect it with this guy over here? So I don't connect this fellow with this guy here. I connect this with this now.
Mm.
You understand the idea here?
Yeah.
So in this structure here, this looks unconnected. But
Yeah.
this is already connected over here.
Okay.
You understand the principle here?
Yes, sir.
In the original compound, which is like this is the one which looks unconnected, correct?
Yes, sir.
So in this particular structure, when I change the structure here, this looks connected to this one now.
Yes. But then they're all connected if you see that is
So everything is connected ultimately.
Yeah.
So the same thing applies to the other one also, which means the only thing which will matter now is, are they going to be electron withdrawing groups or electron donating groups? They're all electron withdrawing anyway.
All of it. Yes.
You're going to be having all of them being perfectly acceptable as acids and very strong ones at that, which means the third should be stronger than the second, stronger than the first.
Mm-hmm.
You understood the idea there?
Yes, sir. Yeah.
I do not agree with option 6 though.
Mm-hmm.
That doesn't sound correct. So we will still go, I will still go with 5, but it's a small controversy. I don't care. I'm not interested in debating whether it's ring chain or chain. Go with whatever your system is going to be taking. If they call it chain, they call it chain. No problem.
Mm-hmm.
So this question, yeah, fair enough. Even if you got this wrong, you can do nothing much about this. What's happening otherwise? Paper is done.
Yes, sir.
Closing thoughts for today. Go into monk mode. You have no options. Sincerely. Your performance is acceptable, but definitely it is not to a standard where you should feel like you have achieved shit. And the advanced performance is acceptable purely because you had partial marking. No other reason. Go into a very serious monk mode for a while before your parents force you into it, and learn to embrace it. You are much younger than me. I tried it out like 3 years back, neuroplasticity, whether it works or not. 2.5, 3 years back, 2 years back approximately. And my entire circle of friends are smokers. I don't smoke anymore. I go hang out with them. I've quit caffeine also now, so I don't even drink chai. I take my water bottle with me every time and I go hang out. What I'm trying to explain is, even at my age, neuroplasticity was achievable. For someone like you, it is going to be far, far more easier. Your brain is much more plastic. You're much younger, much younger. It is going to be very irritating. It is going to be very painful to accept it the first few times. How do you do it? You smile. Change that frown on your face. Smile. You're going to enjoy going into a monk mode. Tell that to yourself every day 5 times. I love doing everything which I hate. That's the approach there. You should love doing everything you hate. Good luck.
Yes. Yeah. Thank you, sir.
Sorry for berating you enough today.
Yes.
I feel it was necessary. Sorry, but you needed jostling, so to say. Good luck going into some kind of a serious monk mode. Trust me, it'll help tremendously. And whatever else I said in the discussion also does stand. Your problems are you are prioritizing time efficiency during your solving of questions more than everything else. That is something you'll have to address consciously. Accept that you have enough time. The only reason why you feel you do not have enough time is because you want to spend time for something else over there. When you go into monk mode, when you have nothing else to do, you have shit ton of time. We all do. Especially for someone as smart as you definitely have a lot of time. I'll see you again. Bye.
Yeah. Thank you, sir.
Have a tough day.
Thank you, sir. Have a nice day.
And smile for it.
Yes, sir.
Bye.
Thank you, sir.
Yeah.
Bye.